Let's continue our study of logical operators by improving our GUI utilities. Here's the problem statement. Let's improve our GUI utilities to do range checking of input data. Range checking is important because it is something that can be done generally for many different cases and then reused. By integrating this feature into our GUI utilities, we end up with a much more useful and therefore much more likely to be used class. First, let's design the methods. Now, we're going to recall our original method signature. It looked like this: int getIntDialog string prompt. There are at least two design possibilities for this. One possibility is doing something called overloading this method. That means using the same method name but using different parameters. If you've been paying attention in the API, you've undoubtedly seen lots of overloaded methods. Now, the other thing we could do is change the method name, maybe to something that would indicate that a range is involved. Now, we could do both. We could have bunches of method signatures here, but there's a problem with doing that, and that is when people look at a great big huge class with lots of methods, they feel overwhelmed, and then they're less likely to read the details and learn how to use the methods. So this is where design is a very difficult balancing act, where you want to have a lot of possibilities available, but not overwhelm the person who's using the class. It's really tricky to get this right. One of the ways that I answer design questions like this is to look at the API. The API has been discussed and rediscussed and designed and redesigned by hundreds of the most elegant Java programmers in the world. These are people who really know what they're talking about, so looking at the choices they've made in design is a good way to inspire our design decisions. It's also really interesting. So let's look at what method overloading would look like. Now, an example where this was done is in the random class. So there's a method called nextInt that returns a randomly generated integer. So that could be anything in the possible range of integers, negative numbers, positive numbers, 0. And then there's also a method called nextInt with a parameter int n. And what it does is returns a randomly generated integer from 0, which is inclusive, to n, which is exclusive. So notice this is an overloaded method because we have the same method names and different parameters. So this is what the design would look like in that case. We'd have int getIntDialog with a string prompt and an int limit, which would return a value between 0, which would be inclusive, and limit, which would be exclusive. We could also have another method called getIntDialog with parameters string prompt int low and int high. This would return a value between low inclusive and high, which would be exclusive. Now, you might think, hey, wait a minute, why don't we make high inclusive? Well, that would be okay. The only problem here is that if you look at the API, you'll see that the high values in all of these ranges are almost always exclusive. For example, it was in the random class. So if you do it differently than that, you risk confusing your users and probably annoying them too. So while you may not be completely comfortable with this low range being inclusive and high range being exclusive just yet, eventually you're going to get so comfortable with that if you continue programming that it's not going to seem logical to do it any other way. So I'm following the model of the API here. Now let's take a look at what the other possibility might look like. An example for this is in the ArrayList class, where you have a remove method that takes an int index as a parameter, and you have remove range, which takes two indices, int from index and int to index. And notice from index is inclusive and to index is exclusive. Now, a possible design would look something like this: int getIntDialog in range. So then you'd have a string prompt, an int low and an int high, and low would be inclusive and high would be exclusive. So that's the design. And of course, we could have a third method like this too. So let's choose our design. The first thing we need to consider is which class is really a better model for our utility methods. So with ArrayList, we were looking at something that had integers that were used as indices, whereas in random, we were generating random data. I think random is probably a better model, and so that's one argument in favor of overloading the methods. Now, the other thing we want to think about is which design would be easiest to remember and use. People like things that are easy to remember, If they have to go and do a whole bunch of reading to be able to use your methods, they'll probably just write their own. In fact, this is one of the fundamental shortcomings of many computer programmers, is that they forget to reuse other people's things. Now, part of that is good because you should be proud of the code you write and you should think the code you write is absolutely fantastic. But on the other hand, failing to reuse other people's work is bad because it means that you're doing a lot of work you don't have to do. And this can be carried to great extremes in some programmers who won't use anything anybody wrote. Very inconsistent with efficient programming. So let's think about it. Are more methods better? Well, how did you feel when we first looked at the JOption pane documentation initially? Or maybe the collections documentation? Didn't it feel overwhelming? Didn't it feel like there had to be an easier way to do this? Probably that's how you felt. I know that's how I felt when I looked at it the first time. So we want to keep things sort of lean and mean. And I really think that the overloaded method way of doing things is the better choice here by this criterion too. Now, another thing you might want to think about is which design would be easiest to implement. And it's okay to use that as a factor to some degree. However, when you're writing a library, your primary concern needs to be with the people using the library, not necessarily with your inconvenience. So this is something I would tend to give low weight unless you're pressed for time. There's a saying in computer science that there's never time to do it right, but there's always time to do it over. It's, of course, quite sarcastic. Really, don't always consider which is the easiest to implement. And frankly, I don't think there's any difference in the difficulty to implement these two in this particular instance. So when you're comparing designs, there's never just one criterion. There's never just one way of looking at it. You have to look at lots of different factors and weigh them appropriately. This is where experience plays a big role. If you were working at a company, you would have coworkers you could talk to make these kind of design decisions. And in fact, talking with other people about design is really a good practice and one I encourage you to use. Okay, so now that we've got our design, let's think about what our test data should look like. Because we're going to rewrite our method with 0 parameters, although I guess I haven't told you that yet, we would accept -5, 0, and 5. For our method with a parameter of 6, we would accept 0 and 5, so notice I'm checking the boundaries again, and re-enter -5, 6, and 10. For method with parameters -3 and 8, we would accept -3, 2, and 7, and we would need to re-enter -5, 8, and 12. So again, checking all the boundaries. Of course, we also want to try multiple re-entry on each method to make sure that that's working every time. So let's implement the design. Now we're going to have 3 very similar methods. I've already created the Java doc and the method signatures just to save us a little bit of time because watching that stuff being typed in is kind of painful. So what we're going to do is implement the most general case. Notice that's one of the new methods. So that's the one that has int high and int low. Then we're going to rewrite the overloaded methods as special cases of this. This will give these methods one-line implementations. Now, why would this be better than copy and paste? Because copy and paste could accomplish this too. Well, the reason it's better is let's say we make a mistake when we're writing the most general case. Maybe there's some super subtle little case that slips by. If we write the other overloaded methods by calling the original one, when we fix that original one, we will fix those other 2 methods too. Otherwise, we have to remember that those 3 were copy and pasted. In general, when you're using copy and paste in a program, you're making a design mistake. And so we really want to watch that at this point, now that we're getting a big enough toolkit to do these things properly. Okay, so here we are in Eclipse. Okay, so here's our new class. Now I've rewritten all the Java doc here so that you don't have to do that. Here's the getInt dialog method with the new parameter high. Notice it's a stub at this point. Here's getInt dialog with the 2 parameters low and high. I've left our original method body in there. And here's our original getInt dialog. Now notice that I got rid of the method body there and I just have a stub at this point. So those are the 3 methods we're going to write. We actually can write this method right now. Because we're going to do it in terms of our other method, We erase our stub and write get int dialog. Now we're going to go between low and high. So since this one accepts any possible value, we want to go between the lowest possible integer and the highest possible integer. Now we're going to need to look at the API to make sure we know what the names of those are. If you think about it for a minute, the class that this should be in is certainly the integer class. Because who else would know about integers? So here's our integer class. Of course, as always, having to do our little search for it. Now, we're going to look at the field summary. What the field summary means is class data. So these are the class constants, just like we created some class constants earlier. So you see right away that we have max value and min value. Those are our maximum and minimum integers, and those are the constants we want to use. They're in the integer class, so we'll call them integer period max underscore value and integer period min underscore value. The prompt will carry through from the original parameter. Our low value, which notice was on the left, will be integer.min value, and our high value will be integer.max value. So there we go. Of course, we need to return this, as Eclipse is reminding us. So we have a one-line method. Now in this case, it's kind of cool. Now let's write our other one. Here, instead of returning 0, we're going to return get int dialog of prompt between 0 and high. So once again, a nice little one-line method. Now we could test these at this point, but let's wait until we fixed this get int dialog method. Okay, so let's think about what the loop should look like. We're going to have a while loop that says while the data is out of range, and inside that loop we want to pop up the dialog and allow the user to re-enter dialog. Now this way of looking at code is called pseudocode, pseudo as in sort of, because it's not real Java code. In fact, it's not real code from any language other than English, and even then it's not real English. But what this is a way of looking at the structure of the code without getting too involved in the nitty-gritty details of the language. This is a really good way to think through code before you get too attached to details. We haven't done this much, but I'll do it more and more as our programs get more interesting. So writing data is in range is pretty simple in terms of logic. Data is going to have to be greater than or equal to low, and the data is going to have to be less than high. What that means is that both of those conditions would be true because we're using an AND statement. Data out of range is actually a little different. This is the correct logic statement here. Data less than low or data greater than or equal to high. Now, for some people, that's going to be perfectly apparent right from the first minute, but it can be subtle for some other people to understand. So I'm going to spend the next few minutes talking about why this is what data out of range looks like. Let's look at the rationale for this. First, let's think of this on a number line. Remember those things that you used back in algebra that the teacher told you were useful? Well, guess what? They're useful. Now, a solid circle means that the point is included, and an open circle means the point is excluded. So this is what our range looks like on the line. So to be inside the range, we're going to be between low and high. Low is included and high is excluded. So we're greater than or equal to low and less than high. And notice that we need to use an AND operator there. The reason we use an AND is that both of those conditions have to be true in order to be included. If we used an OR operator, if we said greater than or equal to low or less than high, we would get the whole number line. Definitely not what we want. So let's take a look and see what it means to not be in range. Well, here is what the outside range looks like. Now notice low is not included in the outside range because it's in the inside range. And high is included in the outside range because it was not included on the inside range. That means we use a less than operator for the low value and a greater than or equal to operator for the high value. Now let's think through that or. The reason it has to be or is there are no values that are both less than low and greater than or equal to high. So if we used an and here, which is the mistake that most people make when they do this the first time, what would happen is you would get nothing. Your loop would never run. So that is definitely not going to work. This has to be one or the other. And in this case, there's nothing that's both. So that's the rationale for the outside range being data less than low or data greater than or equal to high. Now, this is actually part of a much more general thing called De Morgan's laws. It's kind of a weird distributive type law for logic, if you studied distributive laws back in algebra. So let's let P and Q be logic expressions. So they would be things like A is less than or equal to low, or B is greater than high, things like that. Here's what De Morgan's laws are. If you take the not of P and Q, you get not P or not Q. So the thing to notice here is both P and Q get negated, and flips to be or. That and flipping to be or is what makes it a weird distributive law. Now, if we use not P or Q, then we get not P and not Q. So the not sort of gets distributed to the P's and Q's, and the or gets flipped to be an and. Now, the rationale for De Morgan's laws is exactly what I gave you in that previous slide. This is just the more general format of it. Now, the thing we need to think about is what does not A less than B mean? Well, if you think about it for a minute, it means A is greater than or equal to B. So when you negate a less than, you get a greater than or equal to. And similarly, if you negate a greater than, you get a less than or equal to. And those flip both ways. This was an example of De Morgan's laws. Now, how do you use De Morgan's laws? Well, in this particular case, it was much easier to write the code for being in range than the code for being outside of range. In general, I would say that most people have an easier time with ands than ors. I think because or has different meanings in English than it has in mathematics. So writing the out of range was trickier. So what you do is write the in range first, and then use De Morgan's laws to create the correct out of range expression. Now, sometimes it's the other way around. Sometimes it's easier to write out of range and then flip it for being in range. So just pay attention and consider different possibilities. So if you remember De Morgan's laws, you can write it the easy way and reverse it if you have to. It's a much less stressful way of getting these things right the first time. Let's go to our code now and rewrite this, our most general method. We're going to need to put our int result. And if we think about it here, we probably want to make it an illegal value. Now that could be tricky because we want to get into the loop the first time. Now remember, because we've called it from the other cases, integer.minValue and integer.maxValue may in fact be legal values. So this is going to be a little bit tricky to get into the loop the first time. So let's put a question mark there, write the while loop and see what we can do. So we want to repeat things while the result is less than low or the result is greater than or equal to high. And I'll make a comment here. De Morgan's from result less than or equal to low and result less than high. And remember to put the not in front of it. Okay, now these should be indented. So we highlight those and click on the tab key, and that's what does the indent. our result string would be JOptionPane, then int result. Now we've had to declare that outside of the method. And the reason we've had to declare it outside is because we used it in the test for the while loop. So this makes sense, except for one little thing, and that's that we don't always want to return result here. We want to look and see if it's legal before we return it. So we've still got some problems with this code that are going to make it a little bit more challenging to solve. So here we go. So let's think about how we could do this. Because we have the test for whether the result is legal up at the top of the while loop, let's move the return result outside of it. If we get there, we've passed that test. So this is a nicer way to do it. We're also keeping the code very short and clean, which is good. Now, the one thing we haven't done here is we haven't told the user if they put in something that's out of range. And that's usually something that's a pretty good idea to do. And of course, we've still got our initialization headache that Eclipse is reminding us about with that big red X that we have to deal with. How are we going to do that? Well, one thing we could do is to move our first attempt up here. This is a little bit like a priming loop. So now, if we get inside that loop, it means that our value was incorrect. So if they enter the correct value the first time, we're just going to go through below. Now we have to remove the string declaration here because we've already declared result string above. That looks pretty good. Let's think it through a little bit. Here now we're giving them a chance to enter the first time, parsing it as an integer, checking to see if it's legal. If it is in fact legal, then we return result. If it's not legal, then we show them the prompt again and do the conversion and check to see if it's legal. Now, the only thing I don't like about this code is we're not giving the user any special feedback on the fact that their value wasn't legal. You have to be a little bit careful about that because whatever we put in here is going to go into everybody's program. So we could use, for example, a JOptionPane show message dialog and say you have an illegal value and then give you a chance to re-enter. But having two dialogues pop up in a row can be really annoying to users. So this is sort of a delicate matter. Another way to solve the problem might be to have two different prompts. One prompt for the first time and then a prompt for the second time. So that would change the signature of the method. Lots of different possibilities that you have to consider, but for right now I'm going to leave it like this. Of course we want to run our program once. Enter a Boolean. Remember the test program that we ran. Enter an integer. Now in this case, we're just calling the one that has any legal value. So whatever integer we want. Enter a double. And enter a string. Okay, so it looks like we didn't break anything, although we haven't tested things very rigorously. The other thing we might want to do is consider our testing strategy. We'll do that a little bit later. Now the next thing we need to do is revise the other methods that are in this class. So we've paid a lot of attention to the integer method, but we've ignored the string, Boolean, and double methods. Well, I have some good news here. The string and Boolean methods have no illegal entries. Booleans don't really have a range, and it's hard to say what could or couldn't be a string. So there are no legal entries that make sense there. But the double method certainly should be revised in parallel. Just as in the previous case, I've created the Java doc and created the signatures. And by the way, I made exactly the same decision with double that I made with int. That is, I overloaded the 3 methods. So here we go to implement the double. So here's the get double dialog with high and low. Now, the one thing we might want to do here is just copy and paste what we did in the integer class. Now, I'm a little leery to do it at this point because we haven't tested this very well. And that means that if we make a mistake, we're going to get it in both classes. Whee! I guess I'll do it anyways, but we really need to remember that we've done this so that we can do the testing properly. So there's the replacement. The only thing will need to be changed is result will need to be a double. And of course, then we'll use double parse double. Still low and high, those are the same, result string, and this will be double parse double again. If you're wondering why Eclipse was not complaining about having integer parse integer there, remember that integers can be promoted to doubles. So this is a case where you have to read the code carefully and remember it. Now let's go and do our 2 other cases. Now this one is interesting with high. We can return get double dialog prompt 0 high. So that one worked very much like the integer case. This one, on the other hand, this was our original method. That one's going to be a little more challenging. Now, the double class doesn't have a min value and a max value like the integer class has. So we're going to need to go and take a look and see what is available. Here's the double class, and here's our field summary. Now, at this point, we can really understand what this field summary is. These are the constants that are available in the double class. So all of these things are final and static. Now, they don't say that they're final in so many words, but they kind of do because they have the caps and underscores convention that Java uses to communicate that something's a constant. So we need to take a look. And we do see there's a max value and a min value, but you need to read these things carefully to see what they really mean, because the max value here is holding the largest positive finite value of type double. Okay, so that's similar to integer.maxValue. Min value, on the other hand, is a constant holding the smallest positive non-zero value of type double. That is not what we want, because we want to get all of the possible doubles. So that would miss all of the negative doubles if we use that value. This is why you have to read the documentation every time. Of course, eventually you'll remember it. But for right now, you need to read and check that things work the way you expect. So let's take a look and see if there's something that makes more sense. We'll look at this negative infinity and positive infinity. Those look promising. So any of our double values should be between negative infinity and positive infinity. Okay, we know how to write that code now. So we're going to return get double dialog of prompt double dot negative infinity and double dot positive infinity. Okay, Eclipse is happy, and we're probably happy too. Of course, we want to run it, but from our last run of our program, that wasn't very satisfying. It's not really an easy way to test the program because we have the booleans in there and the strings and the ints, and we're going to lose track of what's going on if we test that way. So let's write a test harness. So what we want to do is to create a test program that we can strategically use to run. And the good news is we're going to get another chance to use De Morgan's laws. So I've taken our test strategy and I've put it in here. So we can see that we want to run with 0 parameters, with the parameter 6 for parameters -3 to 8. So we have these 3 different possibilities, and we want to try multiple reentry on each method. So those are the things we want to be able to do. And this is our old test program that we had. Now, we haven't changed our Boolean method or our string method, so we probably don't want to test those too much, but we should test them occasionally. Bad things happen to code when you have it open, so never trust code to not have been accidentally changed. It's just too easy to make a mistake. So let's rewrite this. So now it's not just a matter of calling getInt dialog. We have 3 different versions. So let's write a menu. Now I'm putting this in a separate method to keep our main program nice and clean. You could write it in the main method if you want, but I like short main methods. So public static int call menu. Now we haven't done much design for this code, so we don't want to jump too far forward before thinking about what it should look like. So do we want to have, for example, 3 choices for int, 3 choices for double, a choice for string and Boolean? That would be, what, 8 choices? That's probably not too many to have on a menu. So let's do that. As I'm doing this, I'm thinking about whether this is the right thing to do. One of the problems we have is that we're going to have to make choices up here based on what answer comes back from here. Now we could put in a bunch of constants, which is something we've done before, and that's a pretty good way to do this. Or maybe we should be choosing just integer, double, string, Boolean here, and then allowing within the integer choice to have 3 different possibilities. Maybe we could even find a way to tag a particular value so that we knew that it meant not to use one of the arguments. So we haven't given much thought to this code, and that's making the code a little bit harder to write. So let's start to do a little bit of thinking about which way we want to do things. So if we continue down this path, we're going to have, we decided 8 choices here in call menu, and then we'll have 8 choices up here. Now 4 of them are there already, so I guess that's not too bad. Okay, maybe our original decision was all right. Never jump ahead with programming if you're thinking that you're not doing the right thing. Always stop and think about the design. And in fact, we would have been wise to consider this design more carefully before starting implementation. Yeah, rather than rewriting all that again, I'm going to copy and paste. Remember, copy and paste is usually a sign that you're doing something wrong, even though we all do it occasionally. Okay, so there are possibilities. Now we're going to need to read in data from the user. Clearly, the main method is going to need to know about the scanner. And we'll need to import it. And we're going to need to pass the scanner to the call method. Now, some very strange things are happening in Eclipse right now. You may not have noticed it, but some of our code is in blue and some of our code is in black, and it's not at all consistent. It looks like we had a funny little double quote in there, and that may be causing those problems. I don't know exactly how that weird double quote got in there, but those things happen, and you definitely want to pay attention to them. When the colors don't look consistent in something like that, it can mean that there's something very, very subtle that's wrong. So we'll now read a new value. So it'll be keyboard.nextInt. Now, that's a perfectly good menu. And notice that Eclipse has now got the colors all right, so it looks like everything's okay there. I'm not Java docking this one, because this is really just for our own personal use. So the next thing we need to consider, once we've got this choice, is we're definitely going to want to repeat this. So while, now in this case, we want to repeat while the choice is in a legal range. Choice is greater than or equal to 1, and choice is less than or equal to 8. Now to do that, of course, we'll have to declare choice before the loop, and we can set it to whatever value we want because we're going to reset it here immediately. All of these are going to need to be indented, so let's do that now. If choice equals 1, well, that was an integer with 0 parameters. That's this one. Now, in this case, I'm actually not going to put curly braces around the bodies of my if statements, mostly just to keep the code a little bit shorter. If I were doing this commercially, I probably would put them there, but we have to keep things on the screen here. So choice 2, remember, was the integer with 1 parameter. And notice with that one, we're definitely going to want to have the curly braces. So we'll have some parameters here. And of course, we're going to need some double parameters too. I guess we should declare our double parameters to be of type double. And let's change the variable names here to use parallel construction. So since our double parameters were double parameter 1 and double parameter 2, I changed our int parameters to be int parameter 1 and int parameter 2. So here we'll do system out print line, enter the parameter. Parameter 1 equals input.next int. That should have been int parameter 1. And here we'll have get an integer and parameter, int parameter. Else if choice equals 3. It's going to be similar to this. So we'll enter the first parameter. And then the second parameter. So then that's int parameter 2. We're going to add that in to the method call. Now it turns out that our testing is going to be very similar. By the way, since that's all of our integer cases, let's erase this. Since we kept our construction parallel, we can now do the very similar thing for doubles. We'll just have to copy this and make a few editorial changes. Okay, so this will be now else if choices for and this will be get double dialog. Else if choice is 5, enter the parameter. This will be double parameter 1 input dot next double, and this will be double parameter 1. Here's choice 6. Double parameter 1 input dot next double. Double parameter 2, input dot next double, get double dialog, enter a double, double parameter 1, double parameter 2. I notice up here that I forgot to change this to a double dialog. Eclipse had spotted that. That little red X is what called my attention to it. So we've now dealt with this case. I notice I had a little extra blank line there. Unfortunately, that was also the case higher, so let's remove that. The other thing that I see when I'm looking at this code is that it looks kind of weird to not have the curly braces surrounding all of them. So even though I thought initially I didn't want them there, I've changed my mind. Ah yes, what Eclipse is unhappy about here is we declared choice before the method. And of course, you can't declare it twice. Okay, 2 more cases and we're done. Else if choice equals, this must be 7 now. So let's remember what choice 7 was. That was the Boolean choice, so that's this one. Else if choice equals 8. Now, right about now, you might be thinking that there must be a better way to do this. And you're absolutely right, there is. There's a tool that's called JUnit that makes it possible to do this very smoothly. The reason we can't use that tool now is it uses programming techniques that are beyond the range of our abilities at this point. But that is something that you'll probably learn about in your second Java class. Okay, so we've done a whole lot of work for testing this program, and that's pretty typical. Let's get our plan for our test data up, and now start running the program. Of course, we may also have to debug our test GUI utilities. Okay, so first let's try an integer with no parameters. And so remember, our plan was to test -5, which came out correctly, and then 0, and then 5, and we can go on testing and testing. I'm going to go to the integer version with 2 parameters because we know that's our boss. Whoops, didn't mean to run that again. Not that it did any harm. So the first parameter we were going to run was -3. The second parameter was 8. And then we were going to test -3. And it came back as -3. And if we continue testing, this is all going to turn out just fine. I'm going to stop the testing here because it's so time consuming. But remember, that's a very important part of writing the program too. Oh, and by the way, I lied when I said we were going to use De Morgan's laws again. Too bad. Keep programming.